Hello and welcome to INE's CCI Service Provider version 5 Learning Path. Today in this course we will talk about BGP path attributes. Specifically it's going to be AS Path Attribute. Now as you know that AS Path is a well-known mandatory attribute, which basically means that it must be present in the BGP update. And because AS Path is well-known and mandatory, it is a transitive attribute. It is sent across to every AS. Anytime an eBGP router, anytime basically a BGP router gives the update to an eBGP neighbor, he would prepend his AS. So AS Path is also a loop prevention mechanism. If I do receive a route which has my own AS, I would discard the route. So we can do path manipulations in BGP if your weight is same, local preference is same, it's not locally originated, then we can do path manipulation using AS Path. So I could probably influence a router to take a longer path instead of the shorter path by increasing the amount of hops of AS, by prepending the hops of AS through the primary path. So to achieve this, we will look at this diagram here. So as per this diagram, we have three routers in AS1, which is R1, R2, and R3. I have R4, which is in AS2, R5 is in AS3, R6 is in AS4. All the routers have been pre-configured for BGP. So my neighborship has been pre-configured between R1, R2, between 2 and 4, 4 and 5, 5 and 6, 3 and 6, and 1 and 3. There's no neighborship between 2 and 3. So all the neighborship has been pre-configured on their physical interface, not the loopback. Besides that, within AS1, internally, I am running an IGP OSPF so that R2 and R3 can reach each other internally through OSPF. R1 has also been pre-configured as a route reflector, because if I do not configure router 1 as a route reflector, R1 would never pass the routes learned from R2 to R3 and learn from R3 to R2. So we've already configured the route reflector on router 1. Now, let's say if R2 needs to get to the network 4.4.4.4. How do you think he's going to route? If he goes from the direct neighbor, how many hops is that? Look at the AS Path attribute. Have we configured weight? No. Have we configured local preference? No. Is it locally originated? No. What's next? AS Path. So if R2 goes directly to R4, it is one hop away, one hop of an AS, which is AS2. If R2 goes transiting R1 going to R3, R3 is XR3. So if it transits R1 through R3 through R6 to R5 and then R4, how many hops is that? That's going to be 1, 2, and 3 hops. Remember, BGP is not a hop of a router, it is hop of an AS. So if R2 goes from R1 to 3 to 6 to 5 to 4, this is the first hop, this is the second hop, and this is the third hop. So which path is he going to take? The neighbor which has only one hop of AS, or the neighbor which has 3 hops? Obviously the lower one is preferred. So that's why R2 is going directly to R4 because of shorter AS path. Let's verify that. I am going to go back to my router, which is going to be R2, and let's verify on R2 by doing a show IP BGP. To get to 4444, he is indeed going directly because of shorter hops of AS. He is going from R4 directly. What about XR3? How do you think, which is R3 as per the diagram is XR3, how do you think is this router going? So if I do a show BGP IPv4 unicast, so XR3 is going directly to R6. he is not choosing through R1 for some reason, because maybe he's not receiving a route from R1. Let's go and verify R1. Show IP BGP. R1 doesn't have any routes from any neighbor. Let's verify why is that, because he should at least receive the routes from the neighbors. Let's do a show run section router BGP. I do have my neighborship. And let's go to 2. If there's some problem in the configs, do a show run section router BGP. I have some route map here, which kind of should be removed. Let's remove that just to quickly verify. So no neighbor. Show IP BGP. I believe my neighborship is up and running between 1 and 4. Let's go back to 1. Show IP BGP. He should learn routes. Let's do a clear IP BGP star soft. So now he has all the routes learned from R2. If I go back to XR3, because R1 has been configured as a route reflector, he should give the route to XR3. So looking back here, now XR3 has 2 choices. Either he can go from R2 or he could go from R6 directly. Which one does he choose? He chooses iBGP right now over eBGP. As you can see here, this is the best. So how is R2 going? R2 goes directly because of shorter hops of AS. R2 is going here. R1 is going here. XR3, which is this router, he is not preferring the eBGP, he's preferring the iBGP because of shorter hops of AS. Because if he goes from R1, it is 1 hop away. If he goes from R6, it is 1, 2, 3 hops away. So obviously he chooses iBGP over eBGP. Now let's do an AS path manipulation where we would make the entire AS R1, R2 and R3, all the routers within that AS, they would transit and go out to reach that 4444 through XR3, which is R3. How do I do that? What I could do is go back to R2. If you remember that in BGP, route maps are always applied in direction of control plane. So what I'm going to do is when R4 gives the update to R2, I would prepend the same AS multiple times so that it becomes at least 4 hops. In that case, R2 would choose R1 because through R1 it is 3 hops away, and through R4 it would become 4 hops away. So I could do a path manipulation by configuring R2 to prepend the AS. Obviously, AS path prepending would only work if your weight or local preference was the same. So let's go to router 2, create an access list that matches 4.4.4.4. Let's create a route map saying from R4, permit sequence number 10, match IP address 1. If it matches, set AS path prepend, and here I could prepend the neighbor's AS. So the neighbor AS is going to be the last AS. How many hops of AS do you want to prepend? What's my neighbor's AS? AS2. How many hops do I want to maybe add? It should be at least greater than 3, right? So let's put maybe 4. So prepend the last learned AS 4 times, which means now when R2 gets the update from R4, R4 was prepending only once, and R2 adds 4 more times the same AS, which means total hop count would be 5 now. Let's go back to router BGP1, neighbor 20.2.4.4 route map from R4 inbound. Do not forget the permit statement in the route map. If you notice that I actually did not give the permit 1000, what's going to happen with that? If I don't give route map, if I look at my show run section route map, I did not give the next sequence number. A route map has implicit deny by default, which basically means that besides this route, all remaining routes would get filtered from R4. We don't want that. So go back to the route map from R4, say permit 1000. So any sequence number above 10. Let's go and check now, show IP BGP. We'll have to do a clear, so clear IP BGP star soft. Let's check. I should see higher hops of AS. So if the soft doesn't work, you can always do a hard reset. You can do a clear IP BGP star, just so that it clears all my BGP neighborship and re-advertises all the routes. So as you can see now, I have received the update from R4. R4 was only putting this AS2. What have I done? Even though R4 is sending me an AS path with just one prepend, which is AS2, I am prepending it 4 more times. So total number of hop counts becomes 5, and now through R1, total number of hop counts is going to be 3, which means he should prefer iBGP over eBGP. Remaining routes would not get affected. Let's verify. Show IP BGP. Once it converges, so as you can see here now, to reach 4.4.4.4, he is preferring iBGP over eBGP because of this is 3 hops and this is 5 hops. You see I've done path manipulation using AS path prepending. The same thing can be done on XR routers also. The commands are different, but the concept is still the same. Let's try the same thing on XR3. So what we'll try to do there is right now XR3 to reach this network 6.6.6.6, it must be going directly. R1 should be going here and R2 would be going here by default. Why is R2 choosing R1 without me doing any changes? Think about it. If R2 goes from R4, it's 1, 2, 3 hops. If he goes from R1, it is 1 hop only. Because I haven't done wait, I haven't done local preference, AS path, shorter hops of AS comes before eBGP over iBGP. So R2 goes through R1. This is by default without me making any changes. But now, we don't want XR3 to go directly to R6. I need him transiting R1, going to R2, from R2 going to R4, to 5, and then reaching 6. That can be done with, again, AS path prepending. The concept is the same, the commands are different. Here we would not create a route map, we create a route policy. Let's try and achieve that. So going back to XR3 right now, if I do a show BGP, you can see that to reach 6666, I am going directly to R6 because of shorter hops of AS. Let's now make him go through R1 by increasing the hop count. So through R6, it's 1 hop away. Through R1 to R2, it was 3 hops away. I would again increase the number of hops learned from the neighbor from R6. If I make that at least 4 hops, automatically XR3 would choose R1. To do that, I would create a route policy. Let's name this from, or maybe, from R6. And this would be if destination includes 6.6.6.6/32, then what do I want to do? I want to do an AS path prepending. So prepend which AS? AS path, and then I can specify the most recent. I could specify my own AS path also, or I could just do most recent, which is similar to in iOS XZ, it was last AS. So let's do most recent and maybe 6 times. Don't forget the else pass, end if, end policy. Let's now go to my BGP neighbor, router BGP1, neighbor 20.6.19.6, address family IPv4, unicast, route map or route policy from R6 in, commit. Let's check my BGP. So inbound I have applied from R6, but outbound I still have a route policy called pass. The reason I have the pass, because as you know in BGP, in iOS XR, when you have an eBGP connection, you would not send any updates to the eBGP neighbor and you would not accept any updates from the eBGP neighbor. So you should have a route policy which basically passes the routes or allows the route to be accepted and to be sent. So the only difference is that I removed the pass from the in, instead I replaced that with from R6. It has an else pass anyway. And outbound, I'm sending all the routes. I'm not filtering any routes. The effect of this would be show BGP IPv4 unicast. To get to 6 now, look which path XR3 is choosing. He is choosing R1 and going out from R2 because it is 3 hops away versus going directly, it is 7 hops away. One was the original, which was AS4, and then I prepended 6 more times. It became 7 hops. So automatically XR3 is now going in the opposite direction towards iBGP. So configuring route maps or route policies, they both achieve the same thing. So you could use AS path prepending to do a path manipulation and make traffic go. You could do it for a specific route. You could use prefix set in route policy. We could use the direct open parenthesis without a prefix set in the route policy. We could match access list in route maps, or we could use prefix list in route maps. Any way you want to match a specific network, we could use prefix set or access list in iOS XE. If you do want to match the entire AS, we could probably use AS path access list to match the entire AS, where we could match regex and then do AS path prepending. I hope this video was informative to you, and thank you for viewing.